So every meter has a full-scale deflection current IFSD. So this is my ammeter here. It has a full-scale deflection current IFSD. So this is the maximum current which the meter can measure. So expanding the current capacity that it can measure requires the addition of a resistor to the meter coil. So in parallel connection, the resistors are put in such a way such that there is a rotary selector switch in which there are ranges for each of the resistors. So I'm going to be describing this parallel connection by using an example. In this circuit connection that I have here, the total current passing through here is divided into the IFSD, which will now pass through the ammeter, and the remaining current which will now pass through the resistors, the shunt resistors, will be I total minus IFSD. If I have the voltage passing the ammeter is V1 and the voltage passing through the first resistor is V2, then my V1 should be equal to V2. Voltage is equal to current times resistance. So like this, for V1 to be the IFSD times the resistance of the meter coil. I have my question here. Design a multi-range DC ammeter using the basic movement with an internal resistance RMC is equals to 50 ohms and full-scale deflection current 1 milliampere. The ranges required are 0 to 10 milliamperes, 0 to 50 milliamperes, 0 to 100 milliamperes, and 0 to 500 milliamperes. The voltage of the meter coil is 50 ohms. So basically the question wants us to find the shunt resistance in the parallel connection, which I'm going to solve. I have my ranges here. I put this as range 1, so on. So I have my formula here that the current, the full-scale deflection current times the resistance of the meter coil is equals to the remaining current times the resistance of each of the shunt resistors. So now for range 1, since the IFSD times the resistance of the meter coil is equals to the voltage of the meter coil, I already have the voltage of the meter coil as 50. I have my 50 there is equals to the total current entering through range 1, which is 10 milliampere. So I have 10 minus the full-scale deflection current, which is 1 times 10 to the power negative 3, times the shunt resistance, which I'm looking for. So I divide by that. So I have my shunt resistor for range 1 as 5.56. For range 2, I have the same thing. 50 is equals to 100 minus 1. So I have my shunt resistance for range 2 is 1.02 ohms. If you do for the rest, for range 3, doing the same way, I'll have the shunt resistance 0.505 ohms, and for range 4, I'll have the shunt resistance 0.1 ohms. So the next video will be about the Iton shunt, which is another connection in the multi-range ammeter circuit connection series.